All right, check it out, fam. Okay, let's say that this is the ball Earth, right? It's not 100% to scale or nothing like that, right? But you know, just for visual purposes. All right, so we got the ball Earth, right? And here we got the North Pole, right? And at the North Pole, that way is up, and we got Polaris sitting over there at the top somewhere, right? All right, so straight down to the center of this ball, right? You'd have to draw a line perpendicular to that north celestial pole, which would be the equator, right? 90 degrees, right? So now we go back to the surface of the Earth, right? Because it's the alleged curvature, right? At the equator, Toronto is right here. It's 43 degrees from the equator, right? So you go up 43 degrees, and this is where Toronto would be, right? Okay, so now this now becomes your up, right? Straight down to the center of the Earth, right? So now this is your up. So in order to see the horizon, we look straight ahead, 90 degrees, you know, straight ahead of us. So we'd have to draw a line right here, straight ahead, and it's got to be perpendicular to your up reference, right? So 90 degrees right here, and this is your horizon, right? This is what they want you to believe. So now for us to find Polaris, right? Polaris is exactly 43 degrees off the horizon, right? So that means this is your new horizon here, and you use a sextant, and you raise up 43 degrees, and you look straight ahead, right? To see Polaris. Sounds all fine and dandy, right? But the problem is, when you step away, Polaris, which is right here, right? Because that's their up, is parallel to your new line of sight. So theoretically, you would never see Polaris because you're looking parallel with respect to its position on the Earth. But that's not what happens in reality. When we look 43 degrees off the horizon, we see Polaris. But when you actually put it on paper, 43 degrees off their horizon, which would be perpendicular to your position on the Earth, would make it parallel to the position of Polaris. Y'all see what I'm saying now? And this is how they fool you, because nobody checks this shit out. 43 degrees off their bullshit horizon makes it parallel to Polaris. So you would never, if you were to look through a scope, you would never see Polaris at that 43 degree angle off the horizon. The only way you can see Polaris 43 degrees off the horizon is if it's flat. So let's say that the circle here is just what's it called? This is the North Pole right here, right? Let's say this is the North Pole, and this is just, you know, extending up, right, into like dead on straight up like this, okay? So this is you got Polaris will be sitting somewhere around here, and what's it called? This will be your horizon, right? Because you got to be 90 degrees to Polaris, and from the horizon, 43 degrees up would be about right here. Would be about right here, right? 43 degrees up off the horizon would be about right here, right? So then you'll be here, and you'll be looking 43 degrees up, which would put Polaris right about here. And it works out perfectly because the distance from the North Pole to Toronto is what is it? 4,209 miles, roughly, somewhere around there. And then you got the 43 degree angle, right? The tangent of 43 degrees is 0.9 something. Can't remember exactly. I'll let you know when I figure it out. But yeah. So anyway, You times that number by your distance, and you know what that gives you? It gives you 2,992 miles. That gives you your height right here. And I would put it right about here. Right? And this cannot be refuted. It just simply can't. That's just how it is. And if you do reverse trig, you can find the length from here to here. The Polaris, from Toronto to Polaris, the distance. All you'd have to do is, now that you've got the height, you'd have to square the height. You square the distance, and then you, because it's a squared plus b squared equals c squared. So you square this, you square that, and it's going to give you a huge number. And then you get the square root of that number, which will be around here. And it's going to be somewhere around the 5,000 miles mark, 5,000 something. Can't remember the exact numbers, but yeah, which makes perfect sense. You got 3,000 something here, almost 3,000 here, and then this will be the longest, which is 5,000, because you're looking at it as an angle. It's just that simple, bro. But all these years, they have us looking off a fake horizon that doesn't exist in reality. Because if the horizon is 90 degrees to your position on the Earth, 43 degrees will only make it the exact same line of reference of the where Polaris would be. It'll be parallel to it. So you'll never see it. You understand, bro?